Hey guys, this is Christian and today I'm going to show you my new automation project that I've built in Kestra, the powerful open source workflow orchestrator that I'm self-hosting in my home lab. And I use this to run any scripts, manage applications, containers, or do any other regular maintenance tasks using Ansible and Terraform, something that we've already covered in previous videos here on this channel. But in today's video, I'd like to show you another interesting automation use case that I've developed for my new website. Remember, the one that we've built from simple markdown files using the Hugo static website framework. It honestly took me quite a while to find out how to do this because I needed to fiddle around a lot with APIs using webhooks, Git, Python and all of that stuff. But it was such a cool and exciting project that I thought it might be useful to show you exactly how I've built this, because anybody who is interested in DevOps and automation can learn how to connect APIs, Git repositories and webhooks in a meaningful way using the Kestra's platform. So I hope you're gonna enjoy it, and thanks a lot to Kestra for sponsoring this video. Alright, so before we jump straight into the automation flow that I'd like to show you, let's first take a quick look at the project plan so you get a better understanding of what exactly I have automated using which tools and how the different techniques and platforms all work together, because otherwise it can get quite complicated. So first of all, as you might know from some of my older videos, I'm mainly using Notion as my note-taking and project documentation platform. I think Notion is really a great tool that is also commonly used in the tech space, and it's really great to store data. That's the reason why I'm also using this to manage all my YouTube video projects. So here I'm uploading the thumbnail for the video, the description, the link to my video on the YouTube platform when it's published. Basically any information that I later also want to publish as a new post on my website. And because Notion recently added a new feature to send webhooks to any third-party system, I've created a new automation for this YouTube video database that will run every time when I change the status of one of my video projects to published. Then Notion will send a webhook to my Kestra automation platform where I'm using this data to process it and publish it on my website fully automatic. By the way, if you're not familiar with webhooks, these are a pretty standard technique in IT. It's basically a term for a simple HTTP web request that it's mainly used in server-to-server communication. So to connect two different systems and send data based on an event or a trigger to another system where it's processed and doing some other useful stuff with it. So in Notion, for example, you can select the specific properties of your database item that triggered the automation flow, like the name of the video project, the title of the video URL, the thumbnail, and so on. And all this information is then included in the web request that gets sent to my Kestra's automation platform. One challenge I had to solve here, because Kestra is running in my local network that I, of course, don't want to expose to the public internet without any security or authentication, I also needed to add two authentication credentials, one for the Cloudflare Zero Trust, so the Cloudflare tunnels that I'm using to securely connect to my local network, and a second one to authenticate to the Kestra's platform via my authentic service. In Notion, you can just easily add these authentication credentials as custom headers. By the way, I've also done separate videos about Cloudflare Zero Trust and Authentic, so if you want to learn more about authentication in your home lab, you can also watch these videos. And then in the Kestra's platform, when the webhook is received from Notion, it of course needs to do some stuff. It needs to first parse the request first, so transform all the necessary fields and variables that are sent with this request into a usable format, and then create a new markdown file from a specific template that will work with my Hugo static website. And then also finally it needs to push these files to the Git repository on my self-hosted GitLab instance where the website source code is located. By the way, when anything changes on this Git repository, it automatically rebuilds my website and publishes it on the Cloudflare's Worker platform. If you're interested in how that actually works, I've already created 2 videos about my new website. That's why in this video, we really just focus on the Kestra automation logic. All the rest is covered in these other videos. Of of course, I will link you them in the description box down below, so check them out if you want to learn more about these topics. All right, so that's basically the whole plan and the automation logic. Let's now take a look at the code of my automation flow, and I'll explain to you what's actually happening in here, because as you can see, it got quite a long document. So let's first start with how Kestra receives and parses the webhook request from Notion. To receive webhooks in Kestra, you just need to add a new trigger from the core plugins called Webhook. Here, you just need to define a key, which is a secret. You also have to put in the URL of the third-party system that will send the webhook. In the Notion automation, you might have seen this URL already. So the first part is the location of my Kestra's platform. Nothing special in here. But then after the API endpoint, you have to refer to the specific automation flow so that Kestra knows which flow to execute when it receives the request. And at the end, you also have to put that secret in that you defined. You can view the specific format that you have to use for the webhook in the Kestra's documentation that will also automatically open up when you select the trigger in your flow code editor. So just replace these placeholders after the slashes with the namespace, the flow ID, and the secret key. To demonstrate how that works, let's go to my Notion platform and switch one of the video projects to publish that I need to update on my website anyway. And in the Kestra's web UI, you should see a new execution that will then run the entire pipeline logic. As with all executions in the Kestra's platform, you can easily view the entire execution log in a Gantt diagram, where you can simply see what step took how long, and you can also inspect the logs. You can see the topology of the flow, or inspect the outputs and metrics of your execution. I think Kestra really provides great visibility into all these processes, so you can easily troubleshoot when something is not working the way you expected it. And the outputs are particularly interesting for my automation flow because, as I said earlier, we didn't want to tell Kestra just, hey, there is a new video project that was published. We, of course, also want to send all the necessary information of this video with that request, like the title, the thumbnail, the video URL, and so on, so that the automation flow can create the markdown file for the website with the real information. So the first challenge was to find out in which specific format the Notion webhook actually sends the database properties, because I didn't really know what were the names of the fields and so on. And in the Kestra's web UI, you can very easily find that out if you go to the execution overview. And when you scroll down, you should see an object for your webhook trigger. In this webhook trigger, there is a field called variables. And in here, you will find all the details about that webhook request that Kestra received, like the HTTP headers it was sent with, as well as the body, which usually contains all the content that was sent with this request. And in my example with Notion, for each database property that I enabled in the automation, it created a new field under the data properties object, like the date, the name, the title, video URL, and so on. So I just needed to click through that to find out where the content that I'm looking for is located. Honestly, Notion does it a bit complicated. It has a lot of nestings and arrays because it supports different formattings of text, which is a bit annoying and sometimes weird to parse. And that's why I thought the first step in my automation flow was to store these variables in Kestra output so I could easily reuse them later in my other tasks. And this is, I think, the recommended way in Kestra because it's a native variable type that you can use to pass data between tasks and other flows. So what I've done is I've added a new task from the type output values. So this I've used to store the variables from the nested body object of the webhook into easy rememberable names. Like the name will later just contain the name of the database object, the title will contain the video title, the description, and so on. Just one thing that was a bit more difficult is the thumbnail, because the thumbnail is not a simple text value, it's an image. And when you use Notion webhooks to send images, it doesn't really send the actual payload inside the request. It sends a specific short-lived link to a storage location that you can use to download the thumbnail from. But this is something I will come back to later. It is just important that we have all the necessary values from the web request stored in Kestra outputs, so now we can use these values to create the markdown files for the video project. Of course, if you've watched my first videos about the Hugo static website framework, you probably remember how this is working. Again, this is my Git repository stored on my self-hosted GitLab instance. This contains the actual source code of the website. And in Hugo, any new video post have to be placed in the content videos folder. So here you can see all the markdown files for all the other video projects. And whenever I want to publish a new video project on my website, I just need to create a new folder with that video project name, put in the markdown file, fill in the values, and push these changes to the Git repository. And to do that, we of course, first of all, need to clone the repository into the Kestra's automation flow. I'm just using the Kestra's Git clone plugin for that. It's pretty straightforward. You just put in the URL of your Git repository and then it gets cloned to the workspace folder. So in my case, this is the URL of my self-hosted GitLab instance where the website source code is located. What might be important to know at this point is that I'm using the SSH protocol. I first tried that with cloning using HTTPS, but that caused a problem later. And that's why I needed to switch to SSH, put in my private key to securely authenticate and so on. Also, quite another important step in Kestra when you're working with Git repositories and you want to access the files from that repository in other tasks later is that you need to store them in one persistent working directory, so at least it is persistent for that actual execution. After that, it can get deleted. But by default, Kestra will always create a new temporary folder for each individual task in your flow, which means if you clone a repository first, the other tasks wouldn't have access to it. So therefore, I needed to use the working directory task and add all the other tasks as sub-items to that, so they all happen in the exact same temporary directory where the first task can clone the source code and the others can also do something with these files. Now that I had this structure, I cloned the repository, I got the variables from the web request, I could finally start creating the markdown file in the videos folder of my website, where I put all the variables that we've earlier stored in the Kestra's outputs. And because this was kind of a more complex task, I thought it would be best to just create a new script to do that. Of course, I've chosen Python for that because it's honestly just the one and only programming language that I really know. Kestra has a new feature implemented in some earlier versions that is really interesting for running scripts. It has now a new tab in the web UI editor that is called Files, which is basically a file storage in Kestra for each namespace where you can upload any type of files that you need to use or access in your flows. In my case, I've just created a new folder called Website where I want to put all the files or scripts that are necessary for my website automation, such as the video generate Python script, so that will generate the actual markdown file, and a video archetype markdown file, which is the template that defines how exactly the markdown file for the video project on my website has to look like. So here you can find also placeholders for all the variables, the title, the name, date, description, and a video element. I will later show you in a bit more detail what that video element actually is. But these files you can pretty easily access in any Kestra task by just using the attribute namespace files and then specify which files you want to include to that specific task. Here you can also see how I'm executing the Python script plugin, where I want to install some Python libraries that I need for the script. The Ginger 2 library, by the way, is necessary for the template and the file creation. And then I just execute the video generate Python script. And what is also important, I of course needed to pass the Kestra's outputs, which contain the variables and information for that file from the web request, as simple environment variables. So I could easily access these environment variables in my Python script. might be a bit complicated for anybody who is not deep into Python programming and so on. I'll try to summarize it at a high level. So by the way, I have also not written most of the script myself. I've actually used artificial intelligence in my Warp terminal to do that for me. But what this Python script will basically do is it parses the variables from the Kestra's output, so it gets from the environment variables, and then it transforms the video URL to extract the video ID on the YouTube platform, because I need to later generate a specific video element that my website renders as a video embedding. To understand how that works, you probably have to watch my Hugo video. And yes, it also took me quite some time and some back and forth with artificial intelligence to improve the script, testing it, and so on. Surprisingly, it worked pretty well and reliably. And if we go back to the execution logs, you can also see what's happening in the script. Sometimes I write some logs to the output console so I can see how it transforms the Kestra output objects. This, for example, is the formatted YouTube description with all the reference links and so on that will later get published on the website. And there you finally can see that the file successfully is created with a new directory with the video project name /index.md. So this is the actual markdown file that got generated from that template. Now, one thing that I probably should also explain when executing Python scripts in Kestra is that you can do this in two ways. So this is also part of a new feature that was earlier introduced in a Kestra version that is called the task runners. Because you can specify if you either want to execute a script as a simple process. So this is really the same as you would just execute these script commands on the server shell where Kestra is installed. Alternatively, you could also use a task runner called Docker. So then you can run these scripts in an isolated Docker container where you can specifically install any tools or use specific Docker images that contain the tools you need for the scripts. And it's really executing these tasks in an isolated process space using the Docker engine. But again, with this task, I'm totally fine with executing it as a simple process. We will later on have an example where I used the Docker task runner because it made more sense there. I've also used the task runner process for the next step in the Kestra's flow. So this is just there for downloading the thumbnail, because as I said earlier, the Notion webhook doesn't actually contain the thumbnail image. It just contains the URL where you can download the image from. It's just a simple shell script in Kestra that uses the curl command to download the thumbnail from that image and puts it into the same video project folder as a feature.jpg image that is automatically used by the theme of the Hugo website as a thumbnail for this post. But after executing all these tasks in the Kestra flow, I had all the information that the website needs to create the post. The only thing that was left were pushing these changes to the Git repository. And this is where I thought about some different solutions. One idea that I had was to fully automate this by just pushing the changes to the main branch using Git. That would automatically trigger a complete rebuild of the website and fully automated the publishing process. However, there was one argument against that, because even my sophisticated scripts sometimes have problems, and there will be, of course, some errors or things that could go wrong. Maybe that could even break the entire website. So I still wanted to have some sort of manual control over the content updates that are actually published on my website. So that's why I thought about not just pushing the changes to the main branch of the Git repository, but instead creating a merge request, which I can then see in my GitLab instance and I can review it. I could even make changes or small adjustments if the automation script got something slightly wrong, maybe in the description text or the URL or whatever. This way, I could still see what's going to happen before it actually happens, and I manually have to confirm it. That, of course, introduced another challenge for me, because merge requests are very much dependent on the actual Git platform that you're using. So that means merge requests on GitLab are different than pull requests on GitHub. And Kestra didn't really have a specific tool or plugin to easily create merge requests on GitLab. So that's why you probably can imagine I needed to write another script or a few commands. And this time I wanted to use the Docker task runner in Kestra, because the tools that I need for creating the merge request in GitLab, this is the glab CLI tool that also exists in a simple Docker container. So I thought instead of installing this on the server where Kestra is running, it might be better to execute all these commands of the task in a Docker container with an image that already contains the necessary tools. So that's exactly what I've done. And here you can see all the commands that I've executed in this temporary Docker process. I needed to pass through some environment variables to the container for the GitLab host and the authentication, my username and email address, because this is needed in Git. And then I needed to execute some commands before the actual pushing process, like adding the SSH keys for the authentication details so that the merge request got successfully created. Honestly, I really struggled with this because there was a lot of authentication and back and forth testing and whatever. So I first of all needed to add the username and email address to the Git globals config because otherwise I couldn't create the merge request. And then I needed to execute some Git commands first to create a new branch for this, adding the files that we've created earlier in the automation flow. And then I needed to commit the changes and push them. And after that, create the merge request using the glab CLI tool for the new video. When I execute this entire automation flow, you can see what's happening in my self-hosted GitLab instance. Here I got a new merge request for this new video project that I just published in Notion. Here you can see the two files that were added to the Git repository by my Kestra's automation flow, the thumbnail and the markdown file, which contains all the necessary information in the exact format that I want. And yeah, when I see this, when I'm happy with the content that should get published, I just have to click on merge, and then it just takes a few minutes until the Cloudflare worker has rebuilt the website with the new content and all the changes and everything gets live on my public website. So guys, I'm super excited about this because it takes me a lot of time, but I don't really know if that matters to you. I hope it was still interesting to see what you can all do with Kestra and how to build really sophisticated automation flows that include a bunch of different steps like running scripts, cloning Git repositories, working with different tools and task runners, and how you can really connect all your different systems to really do something useful with automation. This at least was a use case that really matters to me. So please let me know in the comments of this video if you like that, if you want to see more of these real use cases. And if you want to stay up to date with all the projects and content that I'm creating, then also make sure to subscribe to my channel. And a big thanks goes out to all of my supporters and YouTube members. You guys are just amazing. You make all this possible. And of course, I'm gonna catch you in the next video. Take care. Bye bye.